Excellent. Good morning, everyone. It's great to see so many of you here today. Actually, have to admit I'm slightly impressed that a talk that started with the word install has brought so many of you here. My name's John Sheehan. I'm an architect on Windows. I'm on the application experience team. For Windows 8, I've focused primarily on the application model for Windows 8 and some other API stuff, some other things. But the key piece that I worked on for this talk is the application model. I've been at Microsoft for a little over 5 years. I joined Microsoft through the acquisition of Softricity. We had a product called SoftGrid. So, how many people are familiar with SoftGrid? Wow, very few. What about AppV? Who else? A few more, okay. So I was the chief architect at Softricity. We built this really cool product that allowed you to take sort of your traditional MSI installation and turn it into a declarative installation. And for those of you familiar with AppV, I think today's talk will make a lot of sense. Before Softricity, I've been around in the industry maybe a little over 15 years. Started in automotive, building vision systems and hardware and software and doing like ladder logic and fun stuff like that. I've got to start a couple companies. So in general, I think I've had a lot of fun in my career. But I have to admit that the work I've been doing lately has been the most fun by far. And we're showing it to you at this conference, and I really hope that you're excited for Windows 8. We're really proud of it. We think that it's really something different and something that's going to surprise a lot of people. All right, so this is supposed to be a chalk talk, but we didn't have an actual session on this topic, so I'm kind of going to make it a chalk session. So I'll do probably maybe the first half of it. I'll do some slides, and then we'll just open it up for questions, because I'm sure you have lots of them. So today we'll talk about a topic that's near and dear to my heart, which is installation and deployment. And we'll talk about all the changes that we made in Windows 8 and how it's very, very different from what you're used to with traditional installation. And hopefully, by the time you leave, you'll understand what our app model looks like, and you'll understand how it affects you as developers. I know you're seeing this word reimagines a lot. We've been saying it a lot. But in this particular case, I really do think it's fitting. When we started Windows 8, we looked at the installation technologies that we had, and inside of Microsoft, we had more than one. And we really looked at, what people had to do in order to deploy a Windows application. And we realized that it was quite a lot. How many of you are MSI developers? A fair amount of you. My team also owns MSI. And, MSI is a great technology because it gives you so much power to do, whatever you want to the system. But it's one of those, things. With great power comes great responsibility. And, more times than not, people would build installers and try to do the right thing. And then, they would start going through testing, and without fail, they'd have lots of bugs. And sometimes those bugs would, kind of be small bugs, and sometimes they would just do really bad things to the system. Just about every product that I've worked on in my career, installation was a big part of it. Like, for example, on the AppV product, we had like 3 full-time engineers that did nothing but our install. And when we would get late in the release cycle, without fail, we would have lots and lots and lots of bugs that were all focused just around the installation, uninstallation, what happens if halfway through installation I reset the machine, all those kind of bugs. And so when we looked at Windows 8, we said, we think we can do better. We think we can take the responsibility off the developer to try to keep the machine in a good state, and instead we can have Windows do it for you. And so we went for a model that we think is very powerful. We think that developers will love it, and we think users will definitely love it. Because one thing we want to be able to say by the end of it is that if you install an app in your system, you can always cleanly remove it and get your system right back to the state it was before. All right, so let's jump into it. I don't want to talk too long because, again, I want you guys to have lots of time for questions. So the key format for this new installation technology is called the AppX package. It's actually really a zip format. Technically, it's OPC, which is an extensible zip format. That's the same format that Office actually uses for Word, DocX, XLSX, those kind of files. You may be surprised. If you go and take a Word docx file and put .zip on the end, you can open an Explorer and look around at the pieces of it. You can do the exact same thing with an app package because it really is a zip file. Inside that file, you'll see all of your assets. So if you have a bunch of images, you have DLLs and EXEs, you have HTML files or JavaScript files or whatever, all of those things are just going to be in there. And they're going to be laid out in exactly the way you laid them out in your project. So it should be very unsurprising. You'll also see some additional things in there. You'll see this AppX manifest that we've spoken about a few times. Alesh and I spoke about it in the keynote, and I'm pretty sure some other people have also sort of drilled down on the manifest. The manifest really is the DNA of your application. It describes all of the services that you can provide to the user. Like, for example, if you are participating in any of our contracts, like you've seen in all the presentations, that information will be in the manifest. Things like, this is my tile, this is the image on it, this is the wide image on it, like all that information is in the manifest. Your capabilities are in the manifest. So if you need access to the camera and microphone, that'll be listed in the manifest. And so really, just by looking at the manifest, we know exactly what your impact on the system is going to be. And when we do installation, we do it based off all the information that's just in that manifest. You'll also see this other thing called a block map. Now, a block map is nothing that you generate. It's something that the tooling will generate for you automatically. But what it actually is, it is a series of hashes for each block of each file in your package. When Alesh said that all packages are digitally signed, he really meant it. And so there's also a digital signature in there. And the combination of the digital signature and the block map means that we can verify every bit in the package and make sure that it hasn't been tampered with. And because we have a block-by-block hash, we have hashes for each block, we can actually validate them right as they come off the wire. So we don't have to download the entire package and then do a hash of the entire package and then figure out if it's been tampered with or not. If anyone tries to tamper with the file, the moment we get that block, we'll know. And then because it's a zip file, you'll actually see, I think I have a pointer here, there's actually the zip central directory. And that's just, you just have to have one of those if you're going to be a zip file. So let's talk a little bit about packaging and signing, and I think the best way to do that is just to do a demo. So I'm going to flip over here. This is one of the few demos you see where there'll be code, but the code really doesn't matter. So I'm going to go in here and to the store menu, and I'm going to do create app package. And I'm going to say build a package to use locally. Say next. It's going to tell me the directory that it's in so I can go and look at it after. Hit next, and it just gives me a summary. Now I'm going to hit build this time, and actually it's going to fail. And it's going to fail on purpose because it's an error that I saw recently, and I wanted to make sure that if any of you saw it, you knew what was going on, and it also helped. It'll also help me it'll help me show you a little bit more about the tools and stuff. So if you look in here, I just got an error, and it's basically saying that there's something wrong with the certificate. Now, when you're building the package on your system, it's automatically generating a test certificate for you. So if you just install Visual Studio and then you start building apps, without even realizing it, it's generating certificates for you. And sometimes, I guess, because this is what I run into, the certificate can have a problem. And I think what really happened was I've been copying this package around from machine to machine to machine. And at some point, I don't know if I installed the cert already, or I'm not really sure what happened, but I ran into an issue. So to fix it, I'm going to go, I double-clicked on the package.appx manifest file, and I clicked on the packaging tab, because we have a whole tab dedicated to packaging, and I'm going to click Choose Certificate. And you can see right now it says Publisher ID none, and that's really the problem. I don't have a real certificate for this package. So I'm going to say Create a Test Certificate. I have to do a password. I'll make it super, super, super secure. And it says it already sees one in the package, but do I want to replace it? Sure. Great. So now I have just generated a certificate for my package. Now let's go and try that again. Go back to Create App Package. I say I want to build one to use locally. Later on, when the store goes live, then you'll build one actually for the store, and then you can upload that to the store. But right now, we'll just do one locally. This is great for testing scenarios. So you've been building your app on one machine. You want to go over to another machine and test it. This is a great way to do it. You hit Next. You'll hit Build. With any luck, now I get success. Now if I go out to that directory, you'll see this latest version here, and you'll see 3 files. So the middle file is that AppX package that I was talking about. This has all the stuff, all the code that I wrote, and any of the binaries and anything else that's in there. There's also the certificate file that I generated, which is, well, I have to bring with me if I want to install it on another machine. Because you can only install a package if it's digitally signed for code execution, and if the cert that it's digitally signed with chains to a trusted root or is a test cert on a test machine. If you tried to install this on a non-developer machine, it would actually fail because it's just a test cert, and so you couldn't take this to one of your devices that you haven't registered as a developer machine and install it. And then there's also just a nice handy bat file that you can run. Now you have to run this bat file elevated. But the reason you have to run it elevated is not because installing an AppX package requires elevation. It actually doesn't. And we'll get into that in a minute. But the reason you have to run it elevated is because it's going to take this test cert and it's going to install it as a trusted test cert in the cert store. That requires elevation. So yes, you have to run this elevated. Technically, if this cert was already in the store, then you could just use the command line in PowerShell to install packages. Okay. And very quickly, I'm going to go inside the AppX file. So I'm just going to go in. I'm going to rename it to .zip. Yes, I'll change the extension. I know what I'm doing. And here we go. So if I look in here, the project had a default XML file, and then it has my images and my JavaScript files, and then here's some other stuff in here. This content types.xml thing is just an OPC thing. If you actually open up a docx file, you'll also see a content types.xml file. Here's the block map. I can open that up quickly, which I've never done before on this machine, I guess. I'll just open up Notepad. No, I won't. That's ugly. You know what, I will open up a Notepad. Let me just do a word graph, and we'll do a font size. We'll make it somewhat bigger. There. And all you can see is there's just a whole bunch of hashes in here. It's literally just file hashes, so it's not a particularly interesting file. There's the AppX manifest, the signature file, which is a standard P7X signature file, and then some more stuff. There's also this resources.pri file here. This is actually part of the localization work that another team in Windows has done. As part of the generation process of your package, we will actually create. It's effectively a table of all of the localized resources. Both you may have localized files in the package, or you may have like the equivalent of string tables. All of those get bundled up and put in the PRI file. All right, so let's get back over to the slides so we can get through this and you can start asking the questions. All right, so when I said before that it was a declarative installation technology, what that really means is that you do not get to write any custom actions if you're an MSI developer. You can't write any custom code. So when the user installs your package, it's installed and it's looking great, none of your code has run. It's not until the user actually launches your package for the first time that you're allowed to run code. And at that point, then you can do what you want. You can update your tile, you can do all those other things. But you don't get to do that at installation time. The installation process is pretty straightforward. You'll be in the store app, and you'll trigger an installation. So you'll say, I want to buy this, this great app. And the store will use the same public APIs that we have available in the Metro SDK for installing packages. The installation process actually pulls the bytes from the cloud, that AppX package, it downloads it and validates to make sure that it hasn't been tampered with. And then once it's downloaded, it goes through the installation process, and then you have your app. Now, installation is per user, and so, which is surprising because typically Windows app installations traditionally have been per machine, which means that when you log in, you see not only any apps that you've installed, but any apps that anyone else on the system has installed. And so we didn't think that was right, because like my daughter and I, we share a computer. Every so often I'll go in there, and on my desktop, which is interesting enough, I'll see like a thing for some Barbie game or something. And there's nothing wrong with Barbie. I just don't happen to play any Barbie games. So in Windows 8, you only see the apps that you've installed. And usually the first question people have is, does that mean that if me and my wife and my daughter, we all install the same app, there's 3 copies of it? And the answer is no. Behind the scenes, we have a single instance store that we make sure that we only have 1 copy of the bits, no matter how many people on the machine install. But when we do the registration, and registration is what we call the process of like updating the system and updating the area that knows about contracts and updating the tile, all of that stuff is part of the registration process. With that, we do it per user. So what we're really doing is we're just updating your profile. And that's one of the reasons why it doesn't require elevation. We know that the package is digitally signed, so we know none of the bytes have been tampered with, and we track that all the way down to disk, and we even track it while it's on disk. So if you go and someone goes in and gets admin privileges and modifies files, we'll actually detect it later, and we'll mark the package as bad. So we know that the bits in that single instance store are good, and so the only other updates to the system are the ones to your profile, and you're allowed to update your profile without elevation. We have this model for installation, which we have things called extension handlers. So if you look in the AppX manifest, you'll see this extensions section. And this isn't some like third-party extensibility thing. This is how we as Windows teams add code to the installation process in a well-factored, scalable way. Talk about this is the last slide, and then we can get into questions. So one interesting thing about the new packaging format that we have is that every time you build a package, you build a full package. Everything's in there, which means that if you are on version 9 of your app, and I've never used it before, I can just grab the version 9 package, and I can install it, and it'll just work. But if someone else has had versions 1, 2, 3, 4, 5, 6, 7, 8, they still get the same AppX package, and they still do an install. But what we don't do is we don't download anything that you already have on disk. So let's take an example. Let's say you had version 8 of your package, and then there was some small bug in say, some line of code. So you fix the bug, you rebuild the package, and you put it back up to the store. If I already have version 8 of your package, and only 1 file has changed, then when the download process happens, I won't download any of the other files I already have. And as a matter of fact, on disk, if you go and look, you'll see 2 two different directories, like let's say, for example, my daughter was using version 8 as well, I update to version 9. If you then went in the directory and looked, in the installation directory and looked, you'd see two versions sitting there. You'd see version 8 and you'd see version 9. But under the covers, if none of the files have changed, we've actually hard-linked them, so you're not using extra disk space unless you have to. On top of that, if, let's say, only a small amount of data in the file changed and the rest was the same, we actually have hashes for every single block. We'll see that those other blocks haven't changed, so we won't download them. So it's really, we try to download as a small amount of data as we can. A lot of people have asked us, do we do some kind of remote differential compression to try to figure out the minimum number of bits we can download? We don't actually do that. It turns out that that's actually computationally expensive, especially on the server. And so when you need to scale to 450 million users and they might download hundreds of apps, you really want to have your servers as dumb as possible, because dumb scales. It's true, it does. And so we don't want any intelligence on the server, and so we basically, there were lots of other things we could have done, but when we looked at it, we really did the math, actually. We built lots of packages, we looked at all the different techniques, and it turned out going to the block level was good enough. One thing you should think about is if, like, you're building a game and you have files that have, like, very large assets, like you've seen some of these games, like these like DirectX 3D games like Halo and stuff. If you look in those games, they have these huge files in them. Sometimes they're a gigabyte. And inside of there is tons of levels and all kinds of stuff. Let's say you wanted to add a new level to your game, and you wanted to put it in that file. The best thing you could do for your users to get them the best experience would be to put that stuff at the end of the file, or only update certain blocks in the file, knowing that when one of your users who already has the game gets an update, they would have a much quicker experience. It would download really fast, as opposed to if you put 1 byte at the beginning and shifted the entire 1 gigabyte file, that would actually affect every single block, and so then they would have to download that whole file again, which would take a lot longer for them. With that, that's all I'm going to say, because I assume that you'll have lots of questions, and I'm not going to be able to anticipate them, so let's just start the question and answer period. And by the way, here's some additional information. This deck should be posted in the build thing. All right, so there are microphones here, and it would probably be better. Actually, you know what? If you just want to sit, that's fine. I'll repeat the question.